All right, he's going to bring in and show a few things here in the interface, and hopefully it'll help explain a little bit more. But if you have any questions during this, let us know at the end.
Yeah, here is the run I did early. So this is August 2009 simulation. Some result already here, but I repeated the step. And like for time series, when we plot the water surface elevation, so we first go to the CMS flow and August 2009, and we find the water surface elevation file here, right? So we check, open the file. And the next one, we define the point. So we want to extract the data from. And here, and we go to the map data and duplicate the array property. And then rename it as observation.
Already got one of them.
Already there. Yeah. I already have an observation point. But anyway. EBS, yeah, OPS. And right click, so we define as a observation point, observation, yeah, from array property. And then we will put the point at the measurement at the tidal gauge. And to generate the point, we check the create feature point. I think the tidal gauge is around here. So we put the point here. And the next one, we go to display. We select plot wizard and check time series. And next, you see is a scalar data set, coverage of OPS, and point is this new point. And then use the select data set on the new grade, right? And there's many here. So we use this one, water surface, water elevation. Yeah, that's the data. And the time label, we need to change here. Time setting. This is still March 1st, 2017. So we go to August 1st, 2009. Yeah. So let's plot again, time series. Yes. Water elevation. Okay. Yeah, that's a 30-day simulation of water surface elevation. To export the data, so we either go view value, right? You see the two columns. You can highlight and then copy and paste to a text file you name. That's one way to do it. The other way is export the data, right? You select a file, and then it's the ASCII file, the text, and then browse. So you give a name, right? You come here, and you give a name, and then see. Already, okay, all right. And then you export all data and label, and the table format, pointer subset, and then export. So the data was there. Data is here. Yeah. So you have your water surface elevation saved here. Yeah. Next one we do contour line, right? So the contour line and a vector. So we get a velocity output file from this folder, VEL H55. So this one we pick a magnitude when we do model simulation, and we can plot the contour line of current magnitude here. And for that plot, we go to display option. And we check the face contour, and then there's those options, right? And you can do contour fill, color fill, or color fill and linear, and just line, or you can just plot the linear, the line, right? So the color map can be selected from here, right? So the default is the legacy hue wrap, yeah. And the line thickness, you can put a little bit thicker here too. And the range, current magnitude range, we specify range from 0 to 1.5, and specify precision. We default is 1, just doesn't matter if we check or not. So legend option come here. It's not depth. It's the contour we are going to do is current, right? Current speed, and it's meter per second. And the font we pick is like Arial bold and 16 size. And the color we use white because it's on top of a Google map. So we use white color. And the screen location of the legend, you see there's a top left, top right, or bottom. And we pick a screen location we specify here. And okay. We didn't check here. Let's see, 20 August 20, 1300. Yeah, let's see the contour plot.
Can you show them how to change that from elapsed time to the actual dates in that time steps window?
Say again?
show how to change from that 18 days, 9 hours to actual days in that time steps window. Do you know how to do that?
What is
It's just going to show them how to do that.
I don't know what you mean. This is August 20, 1300 hour.
I know. Could you go back to that dialogue where you were entering the reference date and time and show them how to do that and change it to absolute
Yeah, yeah.
instead of relative? Change it to absolute. Down below. Yeah.
Yeah. Yeah, you can do this.
And it's a lot easier to find your dates and times there.
Right, right. Yeah. Yeah, this is 1 p.m. Right. Okay. The next one is we do a vector plot for this output. Like we show early, so the vector plot, you first select, vector, this option. And you can check here at each node and cell. That will be very dense plot. So on the grid, you can specify the density of the vector. So we put 20, 20 in both direction. And relative to bed, we put 10 here. And the range is from 0 to 1.5. Scale length to magnitude. Yeah, that's scale. And I said you can change the color of the vector. I think Mitch, here is a bug. I tried to change it from black to white, right? Yeah, I chose solid color here, right? So I check white color, right? It's white. But when I plot it, it show white. But the legend here is not show white. Remember, it's show legend. Current meter per second. Oh, okay, it's good. It's white. The other day I did on some other machine. It always show red. I don't know why.
Hmm.
Yeah. So I can put this vector down below. It looks better, right? Okay, you can change the location. Yeah. Legend. So I move this maybe 20x. Yeah, I put it here. Okay. So that's yeah, you change the time. You see the current field change. So the next one we said we compare the data with the model with data, right, on those transect. So first we need to bring in the transect, and then we go to our folder. to find this GIS data set, August 20. Yeah. So open this file and use the import wizard. Yeah. Okay. And then space, tab, and then next. And then you come here. So that's the GIS file looks like. And you have X, Y coordinate for the data set. And then you need to specify the vector U and V. And this is U, Vx, Vy. And then you come here, like this is the vector X. So give a name. This is Vy vector. So finish. Specify projection for the input data. So that's the state plane, New Jersey. Coordinate state plane. It says NAD 83 meter, and then we find in state plane, New Jersey. Okay. Okay, we have those transect here, but we don't see the vector yet. Let's specify the vector feature here. This is a scatter point. So on the scatter point, we have a point, we have a velocity vector. And we specified some feature for the vector at each node and cell, right? Relative to bed, put 10 here, 0 to 100. This is a centimeter per second. And legend. So we can put legend here too. I put a location here. Okay, so we see those vector here, right? So the legend is here. Yeah. Next one, as I mentioned, we want to compare the results with model, right? And for that, we generate an observation arc, yeah, along this transect, and that's kind of a from here. It's a slow machine. So here we already have a observation arc, but we can do from scratch. If without those, we can go to map data, like duplicate arc. I will name it. Same as we generate a time series point. Observation arc 1. Yeah, it's observation, right? And then we will generate an arc, okay, create a feature arc. And then we generate an arc along this transect. To make the point approach to the survey is kind of need to be very careful. Otherwise, if your point is off, the SMS couldn't interpolate the value, extract the value properly. Yeah, yeah. So after you generate, I just use the old one. Yeah, you see the arc, and the arc has a direction point to the ocean side, and right click the arc. You can reverse arc direction. You can redistribute vertices, right? You see this average spacing is 9.58. So you can specify as 2 to make the arc much smoother. Yeah. That right now you see the arc, what we got, the velocity, we only have a vector here. So to calculate the speed and direction for two scalar data set, and you can go to data set toolbox and then convert it vector to scalar. So current, magnitude. So give a name here. And also, I mean, the unit is a centimeter per second. So I want to convert the units to meter per second. So we go back again to data toolbox and use the data calculator. And we have a magnitude, current magnitude, double click times -1. Magnitude. Yeah, we got a new data set. And for this data set, so we can compare between model and data along this transect. And the way to do it is we come to this observation arc and we go to display, plot wizard, observation profile. Right. So coverage observation and arc 1 and specify the model and the data, right? And the model is the current magnitude. The data is the current magnitude in meter, right? And then we pick time, August 20. 1300. Oh, the 1 p.m. I finished. Uh, no, right. Uh, I I'm not sure what's going on here. Both model and data. Is positive. I don't know why this comes a negative value. Those steps should be okay. Yeah, this looks all right. Okay, I redo this. Let's pick current magnitude and this new one. Yeah, it plot this time plot data all right. I don't know why the model result didn't plot right.
Well, isn't your one data set's in centimeters per second and the other's in meters per second? Did you make a conversion?
Oh, yeah. This one I forgot. Yeah, I didn't do it. Thank you. Yeah. This one, yeah. Yeah, converted to meter per second. Right. Okay, I know. Yes, model and data, this one. Yeah, yeah, we got it. Yeah, this one, you see the gap. So that's because the profile we generate arc is not, I mean, cover all the data point. And so usually if you want to a good plot here, you need to adjust more about the feature arc. Yeah, this is a vector and a contour plot. And next one, we will see the sediment transport like across a section here.
Hey, Hung Ai,
Yeah,
before you move on, can I show something? I have an easier way to create that feature arc that exactly matches your transect points.
okay, okay.
So I'll just share my screen just real quick and then you can take it back in a minute.
Yeah, shall I stop my sharing? Or
You don't have to.
oh, okay.
Let me close some of this stuff real quick. All right. So he loaded in these transects and we've got the velocities there. And I just read them in like that. But if you want to create a feature arc that exactly matches, what you can do is actually bring that file back in exactly like you did before, except instead of choosing scatter set, you can choose feature data. And it'll ask you if you want to map them all in one continuous arc. And then we can choose or make some changes to get it exactly right. So it'll actually bring it in. I don't know where it added it. Hmm. Oh, activity is where it put it. I shouldn't have put it there. I should have created a new one. So let me do that again real quick. Anyway, you bring it in. You can switch this to feature data. We're going to create a new arc that's observation and give it a name of something different. We map the projection and then it comes in, but it's all connected together. So what we can do is we can just take the select vertices and we'll choose the one at the end here and the one at the end here, the one at the end here, and the one at the end over here, and convert those to nodes. And then we can remove these two arcs. And then this arc exactly matches
Original.
the original. And so you've got exactly the same points. And so you should be able to do a better correlation when you're comparing these together and
Yeah,
you're not missing any spots.
that's good.
Anyway, I'll stop and give it back to you.
Okay. Okay. Yeah, next one is a sediment flux. Sediment flux. And for sediment flux, we need the transport output from the model result. As we mentioned earlier, we go to output folder, August 2009. We have a transport file here. You see there's a for morphology change and depth change, there's another file called MORPH H5, and it's not within this transport file. So this file only have total transport and sediment concentration and sediment capability, capacity, yeah. And for get sediment flux, so we need generate a transect, right? Generate transect, and similarly as we generate an observation arc, right? And we again go to and generate. We copy every property, and we specify as an observation, and we got an observation arc. And to do that, we create a feature arc, like where you want to calculate that. So we can click 2 point. So generate this arc, and to get flux from here, as we mentioned, we need to generate a data set 1 with constant value 1. And that one we will, of course, we need the water elevation scalar file, one scalar file, any scalar file. And we go to data calculator. And data calculator and water elevation water elevation we use all time step, right? And double click this and times 0 plus 1, right? So we give a name equal 1 and compute. So it generates with all time step. The data set has constant value 1. Okay, done. And then we go to display plot wizard and time series. This is the time series plot. And here we select flux. Observation arc 1, and this is the time range. Because it has some 2017 output here, so. Arc 1. That's 1. Total sediment transport and 1. We click both, right? And then finish. Yeah, some feature under SMS is kind of running slow from time to time, from version to version. Yeah, so that's the flux. So after you get that, it's you export the value, right? You either view value and get output, or you you go to export, like we mentioned earlier, right? Same way you do this. I don't repeat here. And then once you save the file, and what we got here is we name the file as flux.txt. Flux.txt. That's the file we save from this plot. You see, that's the file we save from this plot. That's the sediment flux. And then we have this program here. One is a Fortran program, but we have an exe file. And one we call sediment is a calculate sediment flux. And the other one calculate water volume transport. And to run this program and use flux.txt as the input file. So we go to a MS-DOS window. So you get CMD here, command prompt. So you come here. And you run this program. Like here is sediment, right? So we run this program. And the model output is the input file, flux.txt file. And then you run it. That's it. And then you got the output, right? Flux statistics. So you got your results in this file. So that's the result from this program. So you get in and out, you get gross, you get net transport. So these are the different units. So kilo per day, kilo per year. So yeah, that's how we get the sediment flux estimate across this transect. And the other one is we do like channel morphology or channel depth change. And that one also we will generate some transect, like same way as we did this transect. And we need to bring another file, morphology file. And that's MORPH, that file. That file has the morphology change and also depth. Depth change with time. The depth and the morphology change. And for the observation, we have we can have draw some transect here, like as a feature arc. Okay, we still use this map feature here, and we draw a transect here. So see the depth change, and this part is easy. So we just go to plot, observation profile, and that should be arc number 2. Depth. Like we go August 1st, hour 0. Go to the end, see the depth change of the 30-day elevation simulation, right? And so that depth change. So it's easy to switch the sign. So the depth is a positive here. So it's easy to use a data calculator to switch sign here. And you just need to come here, a data calculator. And data calculator depth times -1, right? You switch to that.
Make sure you use all time steps.
Use all, sorry. Yeah. It's all times. Double click. Yeah. Compute. Done. Yeah, you go back. You plot observation profile. And it's arc 2. Depth 1. Yeah. Yeah, that's a reverse sign. Yeah. That's about it. Yeah. Any questions? Maybe too simple for most of you guys.
Yeah, Bruce, do you have a question?
Sorry, yeah, just the output on your sediment transport calculation. I saw the units were in kilograms. Is that information available anywhere? Like the units, is that within the SMS, or how do we?
Yeah, if you go to a SERP there's SERP website, there's a CMS documentation portal. And under that, there's some description of the sediment transport unit there too.
Okay, so there's no metadata within SMS for these different data sets.
I believe we write the units to the binary file, but whether or not that unit is visible from within SMS when you bring it back in, I don't think it is. I'm trying to check on that right now, but it shouldn't be hard for us to get them to load that in, and it would be available under properties for that particular data set if you right click on it. But I don't see it right now.
Yeah, I try, it's not in now. But, okay,
Yeah.
that's all right. I mean, the manual works too. Thanks.
Yep, we'll get that added so that it does show up in those properties under those data sets.